Morning, ladies and gentlemen, esteemed guests, and distinguished speakers. A very warm welcome to the distinguished lecture hosted by the Hong Kong Academy of Engineering Sciences, in short HKAES, and the Policy Research Center for Innovation and Technology, PRECIT, at the Hong Kong Polytechnic University. I'm Engineer Dr. Alex Chen, Senior Vice President of HKES. Today, we have the privilege of witnessing remarkable presentations by the esteemed recipients of the Guanghua Engineering Science and Technology Award. They include Professor Michael Liu and Engineer Professor Alfonso An. Their expertise and achievements have brought them to the forefront of their respective fields. And we are honored to have them share their knowledge and insights with us. Throughout today's lecture, we can expect to be both enlightened and inspired. Liu will enlighten us on a journey and limitless potential for large language models. And Engineer Professor Ant will take us into the fascinating realm of material-driven micro-robotics. Today's lectures are part of the Hong Kong Engineering Science and Technology Award Program, generously supported by the Innovation and Technology Commission, ITC. We extend our heartfelt gratitude to the ITC for their unwavering support, as without their partnership, HKES would not be able to continue its mission in promoting excellence in science and technology. To all our attendees this morning, I encourage you to seize the opportunity, engage with our distinguished speakers, ask questions, and actively participate in the ensuing discussions afterwards. Let's embrace the spirit of curiosity and intellectual exploration that propel us forward as engineers and scientists. Without further ado, let me commence the first distinguished lecture by inviting Professor Liu, and Professor Liu, the stage is yours. Thank you.
Thank you, Chairman. It's my pleasure to come over here to give you a talk about this hot topic called large language models. First of all, I'd like to know about the background of the audience here. Whose major or your background is related to computer science or computer engineering? Can you raise your hands, please? Okay, a few of you. And I think this is probably an appropriate way for me to introduce this topic to you. So this topic, I put it down as large language models. How long did they travel and how far can they go? We all know that the large language models has permeates the whole world right now. It is in fact an answer to the field called artificial intelligence. Artificial intelligence has been with us for like more than 60 years because people were thinking about if we can make a computer, which later we call a machine, can the machine have the intelligence like human being? So in the beginning, the vivid imagination of such a machine is a robot, is a bot that can speak with you. 1966, there's a machine called ELISA, and note that this is an important year about the beginning of the realization of the artificial intelligence. ELISA can talk to people, and at that time, you can see that the computer is still very primitive, but already it can try to answer some question to you and try to particularly comfort the people who needs some kind of psychological consultancy. However, if the question becomes too complicated, then ELISA will try to answer the wrong answers to some of the simple psychological questions. Later, after ELISA from MIT, later in Stanford, there's a machine called Mycin, and that's to try to mimic the doctors consulting with the patients. And that's the era called expert system. I remember when I was just a college student, and that became a popular thing. You know, expert system catch people's imagination. But quickly it dies down because that expert system is no expert anymore because he couldn't answer some simple question. But then in the end of the last century came with the birth of Deep Blue. And Deep Blue is a typical machine which actually can beat those chess player, the champion Kasparov. And that was amazing achievement. But this actually is used a lot of computation and parallel processing. So this is not just an AI machine, it is a parallel processing kind of machine, which caught the attention of the whole world. But at that time, Chinese people will say that that's just a chess, no big deal. Can you beat the Go, which is kind of the invented by Chinese people? And lo and behold, AlphaGo turned out, if you remember, just 7 years ago, AlphaGo, caught the whole world by attention because this is not a simple chess. It's a Go game. You know how complex is a Go game? You know the complexity of Go game? 10 to the power of 100. Do you know the complexity of our universe? How many atoms are there in the whole universe? 10 to the power of 80. Complexity of Go game is 20 order of magnitude more complicated than our universe. And in this kind of complexity, human lost to the machine. So that was really amazing. But then a lot of people say, this is just a game playing, no big deal. You can only play game. You couldn't do any other things. Indeed, that was the case. So we didn't call that this is general artificial or AGI, artificial general intelligence. This is very specific to playing the game. And people were not worried about that. So what's the big deal with that? All this so-called the early version of AI, they essentially are based on either rules or the data. And we call them as analytical AI. Analytical AI analyze the data, identify patterns, and gain insights in order to do the decision and try to make the predictions, like the Go player, like the AlphaGo, because it's constrained in certain kind of a well-defined domain based on the rule and based on the limited combination. 10 to the power of 100 is still a number, limited number, right? So in that kind of domain, human lost to machine, there's no big deal. Right? And at that time, nobody paid attention to another type of artificial intelligence called generative AI. The company called OpenAI silently worked on this for 8 years until the end of last year, November, not even a year. It was November 30th that ChatGPT was born. So ChatGPT is a generative AI. The idea is that you just feed into the data that people can create. In other words, it's just language, which is a textual data, as well as the images. You just feed that in, and then the model is very simple. It will just try to predict what's the coming. In a sentence, what's the coming word? If you can predict what's the coming word, it can predict what's the coming sentence, coming article, and coming everything. And the whole world with the data, including the textual data as the image data, if you can remember everything, you can make the prediction of what's going to come. Then you can try to reconstruct the whole thing. And lo and behold, not only that the machine can remember things, but also it can try to reason among things, and it can even create something new. So that's the amazing part. And represented by Midjourney for the graphics and ChatGPT for the languages. And later on, the amazing thing is that ChatGPT, it handles languages. But think about that, human beings think, our thinking or the production from human being are just a sequence of symbols. So it's just a language, okay? Not a spoken language, but some type of language for communication. And this comes back to the well-known Turing test. Turing test is a test proposed by Turing that if you are talking to something with a wall in between you, you cannot distinguish whether it's a human or AI. You cannot distinguish that. Then that machine passed the Turing test. And what happened now? Once ChatGPT came out, ChatGPT passes Turing test, a turning point for language model. That was the beginning. And ChatGPT broke the Turing test. The race is on new ways to assess AI, not just for languages, but for a lot of other applications. And ChatGPT has passed the Turing test. If you are freaked out, you are not alone. And that was happened just within the past 11 months and 15 days. Okay. not even the whole year. So this is what the ChatGPT brings to us. And in fact, this way of developing the generative AI started from 2019 and just right now. And GPT-4 came out about 7 months ago. And now there's a GPT-4V. Everybody is building the large language model nowadays. Okay? And large language model has an impact to our society. So I'm going to go through 4 different areas: natural language, vision, programming, and some more complex tasks. We start with the natural languages because large language model is based on languages. And in the language model, once the ChatGPT was rolled out at the end of November, OpenAI didn't publish anything regarding its performance. It just released the software, let people use it. Within 1 month, close to 1 billion of people access the ChatGPT. And so professors usually are trying to, we are very suspicious about anything, right? So professors in United States and in Hong Kong, we try to evaluate GPT and see how it goes. And what's surprising over here is that for many of the language-related tasks, arithmetic reasoning, common sense reasoning, symbolic reasoning, logical reasoning, everything, there are already very specific model built for that. ChatGPT as a model, for one model, try to solve every question. Would that be possible? It turns out the performance is amazingly very well because the ChatGPT can quickly get close to the fine-tuning, which are the representing as a state-of-the-art models in order to answer each of these tasks. So that was a study regarding the work from United States, and Hong Kong USD has this paper published in order to look into several other type of natural language processing kind of tasks. Again, it's immediately close to the state of the art, which are the other type of models in different kind of area. So that was amazing, regarding the performance. And OpenAI later released the performance of their ChatGPT regarding how well it can pass the human test. Remember, these are the tests that the SAT test, the GRE test you about general knowledge in language or specific knowledge about mathematics, physics, and everything. It actually performed amazingly well regarding its marks. And what's surprising to people is that after ChatGPT was released last November, 4 months later, OpenAI released GPT-4. And GPT-4, just within 3 months of releases, it actually beat the ChatGPT as the blue, as a yellow mark, is the improvement among different aptitude tests or GRE tests. In other words, it can not only already have human knowledge, but it evolves so fast that you cannot imagine. In other words, it can learn quickly, faster than the human being. And as of now, the large language models still evolve very, very dramatically. And this is an experiment I like very much. You can ask ChatGPT to do some creative task. So if you put a prompt, ask the ChatGPT, can you write a proof that there are infinity many primes? In other words, there's no largest prime number. How do we prove it? Usually I ask my student try to do that, and some students can do it. You can prove it by contradiction, right? Assuming that there's a prime number, then you multiply all of them plus 1 must be a prime number. By contradiction, there's no largest prime number. Okay, you ask ChatGPT to prove this, and you ask it to give the proof with every line that can rhyme. And you give the following answer: oh, yes, I can, though it might take a clever plan, blah, blah, blah. And the key thing is that multiply them all together and add 1 just to be clever, because in that case, there's a number which is a larger prime. So by contradiction, then there's no prime number. And every line rhymes. In other words, what are we facing right now? We are not just talking to a machine next to a wall. We're talking to a superhuman being, or 1,000 experts who includes a mathematician and a poet, to name the list. Okay? So this is what happened that the ChatGPT can do. And it can also give some creative kind of work. You ask the ChatGPT to place a book, 9x, a laptop, and a bottle and a nail. stack them together, but it will be stabilized. So if you as a human being, you need to think, how does it work? And it gives you the right answer in this way. Okay, put a book, put 9x, stack them with the laptop, and then so on and so forth. And it was a very elegant solution. This kind of question, ChatGPT shouldn't have seen it before, and it still can solve it. All right. So in other words, this kind of creativity can be seen just by natural language models as examples. How about vision? In the vision area, we found that the GPT-4 with vision, GPT-4V, which came out just a few months ago, give it some images and it can tell you what does the image represent, right? So mathematic image being shown on the above, and then it can give you, these are the formula in the type 2 font. And if you give it these two images, it can tell you there are defects in the image. And this defect, it can also give you the reasoning regarding that. And finally, if you give just tell the GPT-4V, try to locate a human being over here, it can tell you the position of this person and what is that kind of person. And this is what we call is a zero shot. In other words, any photo, it can handle that. You just give it a photo. So the large language model nowadays is essentially a pre-trained model. Once it's being pre-trained, you don't touch it, but then you cannot train it anymore, but you can consult it properly. And we call it as a prompting or prompt tuning. Using the appropriate prompt, you can extract the knowledge of the power of the pre-trained model, which is like a large language model. So this is how it works. And this is another interesting demo called Dolly 3. Can we have it play? So Dolly 3 is a sort of automatic generated cartoon, and you can just talk to this cartoon. So you type saying that my 5-year-old keeps talking to that, and then GPT, this machine will give you the animals that the kids would like. And you say that if you can generate something, and it will generate according to the prompt. In other words, you ask it for something, particularly in the children's language, and then you can show like an expression from this sort of the cartoon character, and can generate some new labels. And you can also try to give it some kind of new imagination or new kind of animation. And it can reply to you either by image cartoons and either the language as well. Okay, maybe that could be all that. So in other words, this is one of demonstration that it can be like a human being drawing cartoon according to the needs of the user, and it can fully understand what the user wants regarding that. Meta also published this segment everything. It can take any image that you give it and then try to segment the images. So on the left-hand side, you can segment the complicated building and separate them properly. On the right-hand side, you type cat, and this image about the cat, it can segment for you. Segmentation of the images in any pictures has been a long research work for more than 20, 30 years, generating more than 1,000 papers, but it's already fully solved by just using the idea of large language models. And another example I want to get into is the area that I'm interested in the most, that is programming. Okay, the ChatGPT, can it do the programming? And the answer is yes, it can do automatic programming. Maybe we can show this video as well. It actually can create a code for you by just simply giving the instruction to that. Right? So you can say, please write a Python program that uses a skeleton library to load the iris data set. These are all very specific data set from different library. Then you can do that according to your instruction. You will load the data set, and then you can run the data set. This part is human execution, but you can ask a machine to do that as well. And the next one, you can say, let's analyze the data set. The code should include the shape of input and other things. So then you will analyze the data regarding statistical evidences. And you can say, write a program that uses random forest, which is a machine learning algorithm to classify the data. And it can write this code. This is a very standard code, but it can be perfectly written Okay, usually take a programmer a few hours to write it, but right now you just prompt it and you give you the code. And then you can say, compute the accuracy of the prediction. You can run it and it get the result for you regarding the statistical result. And you can, call another machine to execute it, run the demo program that was executed, and then it can give you the result as a result. Thank you. So this is sort of automatically generate the code just based on the human instructions. And another example here is that you can do the code completion. In other words, if you get into more complicated code, you try to type, the programmer will try to type the code, and along the way, please continue, along the way that you type it, it will give you suggestions. So the way that you program it is just give the comment. So # sign, after that is comment. And you give the comment regarding that this is a demo showing the hacking trainer to call the hacking face, which is a deep learning kind of machine, in order to be able to do some proper computation. But it will require that you load the data and try to separate data in training set and the testing set, and then try to execute according to certain kind of machine learning requirement. So you say that first load the data set, okay, and this is again just the comments. Then when you type just a few words, typing the instruction, you'll give you suggestions, and you'll complete the rest of languages. So you just hit the return, select it, and then you can say split the data set into the training set and a validation set, and you'll do that for you according to what it should be in the programs as it's written. This is a Python code, so on and so forth. So maybe that's all, okay, due to the time. So if you can believe me, the ChatGPT already can be a programmer, and people have done a test. It passed the Google level 3 programmer testing. Okay? It passed the level 3. And what's the salary for the level 3 programmer in the United States? $185,000 US every year. In other words, if you're making the salary below that, you will be out of job because they can just use ChatGPT to do all this kind of work. Right? So that is not it's not threatening. This thing created by computer science people, it's not just threatening the people in non-computer science field. It is also threatening the computer scientists. So I told my students that if you don't know about large language model, be careful, your job will be replaced. So make sure that you know what ChatGPT can do, and you should do better than that, right? So these are the programming language area, and I will get back to that because my research is related to software engineering. And the last one is a complex task. So far, the task I gave it to you is more or less a single, even though it's very deep and it's not that easy. But the GPT can even do the complicated task in the following, in the sense of that it can decompose the task and then put them together. Okay, so one example by Microsoft is called AutoGen, which is a framework that will enable diverse large language model-based application using multi-agent conversation. Each agent is just a large language model, and you can let them communicate with each other. So agent classification, it will include, like in this example, we have these robots and this type of robots. And the way that they can communicate can be multi-agent conversation or the flexible conversation, including the joint chat or the hierarchical chat. And finally, you can let two chatbots to talk to each other regarding a particular task. So one asks the other, try to plot the Tesla's stock and price, and then the other one will try to plot it. And this one will say, oh, there's some problem with that. Please make the correction. The other one will do the correction. And this one will say, oh, the output doesn't look like what I like. I don't want the value. I want the percentage. And the other one will do that for you. In other words, through the interaction of the machines, it can do some tasks without any human interventions. In other words, they can do all their work for you and you don't touch them. In other words, that means that some people may be worried about they'll be out of jobs, right? But this is sort of just a potential capability that is, but in the long run, there's still hope. I would say that there are more complicated things human can do. But getting back to another example by MSI, Microsoft, the ChatGPT can actually become a supervised for a series of tasks. So if you give a GPT some kind of work, it will do some task planning. It will do some task planning, planning a task, and then do some model selection, select different models for you. And then you can run this model to accomplish each of the tasks, finally integrate together to give you response. So these are already like a task manager to manage a series of tasks. And a demonstrating example is that if you ask the Hugging GPT to draw a diagram like this small kid with a similar gesture, but it should be a different kind of photo, then the Hugging GPT in this example will generate, according to the gesture of the kid, draw a girl sitting on a sofa instead of riding a bike and reading the book. And finally, you can ask this diagram need to be explained and verbally pronounced. So these are the explanation about this image, and verbally can pronounce it. So this kind of task require a series of subtasks, and it can be all done by the Hugging GPT in the way similar to how human being will do it, except it will be much faster. Okay? And so for this, that I hope you are convinced that there's a reason why ChatGPT, when it was rolled out, it hit the whole world by a big surprise. Okay, in the beginning, people was doubting about it, and later was sort of amazed about it, and sooner, more recently, start to worry about it. Okay, but what I want to say is that in fact, we need to do some research to really look at its capability more. So in the next few slides, I'm going to address in more detail, I do have some time, regarding specific tasks you can be doing and how to use that to do research. So this gets to the research work I have been doing in the past 3 years. I'm doing the area of artificial intelligence as well as software engineering. Okay? And the idea is that we can apply artificial intelligence technique to software engineering. So traditionally, software engineering was done by so-called rule-based or so-called static analysis. But with the AI capability, namely the machine learning capability, we can do data-driven rather than rule-based way to handle the software engineering. So apply this AI to software development. That's the area I call it the artificial intelligence for AI development. And now artificial intelligence represented by large language models. And we can apply the large language model to the operation of the system. We call it AI ops. And that's large language model, AI ops. But reversely, we can also apply the traditional software engineering technique for the robustness of the artificial intelligence. Currently, even though AI or large language model can do a lot of things, but they are not robust, they are not safe, okay? And a lot of time that they are lying seriously. Okay? And you cannot tell which part is lying, which part is a serious talking. Right? So robustness of large language model can be achieved by the traditional software engineering approach. So because of that, we have a series of tasks in each of these 3 areas. So I'm going to start with the first area, which is large language model for the AI development. In the AI development for large language model, key thing for the software development is the code intelligence. Example is like the code generated by the demo that was given to you earlier. But the key thing then is that how can you ask the large language model properly in order to produce good code for you? Okay? And what happened was that we know that if we do a machine learning model using the pre-training, once it's trained, the previous way before the large language model, the previous way is that you will try to fine-tune a new model by adding a few layers in the deep learning architecture in order to get the results. We found that that kind of approach would not be as accurate as using the prompt learning, prompt or so-called prompt tuning. The idea of prompt tuning is just you give the prompt in order for the machine learning model to respond. And that kind of prompt can be flexibly designed according to how the pre-training was done. And because fine-tuning and pre-training are often in different domains, the result will be inaccurate. But because prompt tuning and pre-training can be very align with each other, the result is supposed to be better. And indeed, that was the case. These are the examples that you can flexibly design different kind of prompt in order to ask the large language model to respond to you. And this I just show the result that it will be better than the fine-tuning kind of approach. So essentially, you will get a 24% of improvement using the prompt tuning instead of fine-tuning. This work was published in year 22. That was before the ChatGPT was released. In other words, we already found that using prompt tuning is better than fine-tuning. And ChatGPT just tells us that forget about fine-tuning. They just give you a large language models. All you are doing is prompt learning. Okay, so pretty much consistent with our learning earlier before they release it. And later, there's another way that you can do a better extraction of the power from the large language model. And it's called in-text learning. In-text learning idea is that you don't just prompt it with one question and expect the answer. You try to prompt it with a sequence of questions. And in that way, then you can get a better result. So this example just tells you that you can give a prompt and then ChatGPT give an answer. Okay. And this kind of prompt, you can include some kind of demonstration and then give some kind of data. So in that way, the ChatGPT can learn what you are really expecting, not just a simple question, but even using the illustration. So because the prompt in the in-context learning, we call it ICL, can be a few terms. So we want to see each term has a demonstration. Whether we select the demonstration using different order of demonstration, using different number of demonstration, and whether we can generalize the funding. So this research question represents a different way of doing ICL. And the answer is that the way that we do the ICL should look into both similarity and diversity in each of the terms regarding the demonstration selection. And we should put at the end the similar samples put at the end will get a better results. Okay. And surprising result is that more demonstration examples actually doesn't help. It doesn't mean that you keep asking a question, eventually it will give you the right answer. Okay. And this is getting to the people what we said about sort of the hallucination, or in the simple word saying is that you are trying to do overtraining of the ChatGPT and the result wouldn't be good. In other words, these are all the parameters we need to look into. Furthermore, we use the domain language or domain knowledge in order to the prompt. And this particular task is to do the type error repair. In the program language, the important part is a variable, and the variable need to have the right type. In the Python kind of language, the type can be dynamically changed. Because of the dynamic changing type, often the programmer may write the wrong types accordingly. So we need to fix the type in the program language. So this example shows that in this Python code, the red part is wrong. That type of this sum of the variables will be wrong, and the green one is the right way that you should correct that statement accordingly. If we do this directly, ask ChatGPT to do that, it cannot do a good job. So what we did is a procedure, and this procedure turned out to make a sort of the solution simple for people to understand. The idea is not just use the ChatGPT, but also use a smart way based on the human understanding of the rule of typing, and design the prompt that asks ChatGPT in a smart way so that it can answer you properly. In other words, it combines the idea of static analysis as well as a data-driven approach, rule-based approach as well as a data-driven approach. Okay, and this just shows that in two data sets, our result, which is called type fix, get new errors that can be corrected, and essentially it increased the state of art by more than 30% of the accuracy. So this is sort of a recent paper just accepted for publication next year. And you can see that there are still a lot of things that ChatGPT cannot do. In other words, ChatGPT can do a lot of work, but it cannot do very well. It can do automatic programming, but the program still has a lot of bugs. It can try to fix the bugs, but some difficult bugs it still cannot fit. In other words, for complicated tasks, it still have room for people try to sort of improve accordingly. And another task is that we can also generate type and try to reason about what would be the type in the programming language. Traditionally, there are three approaches to that. One is called rule-based. Based on the rule, you can derive the type. Second way is you supervise learning, that you understand a lot of programs, what should be the type, and you try to build a model in order to predict the type properly. Or you can directly use a large language model like Colbert in order to directly view the type. None of these three traditional approaches will work properly. So again, our design is to combine the knowledge that a programmer will have and build a database to extract the appropriate program. So these are the Python source file, as well as the target Python source file that you want to predict and generate a type. And the whole thing here is just combine static analysis with the power of the large language model. Again, the result get very impressive thing. That is, our approach can beat all the other state of that by a large margin. Okay, and this paper just received a distinguished paper award in a top conference nowadays. So all these are just quick example for you to know in the AI dev kind of area, how things can work. How about for the AI ops area? AI ops means that there's an operation of the software in large systems. Can AI help it automatically? And this is a task actually I work very closely with the company. I work with a cloud provider company. They have very complicated AI operation system. Their notation is about, let's have a self-driving capability in our cloud. Remember, self-driving car is something everybody talk about. They're talking about self-driving capability, like self-driving car in the cloud environment, meaning that whenever there's something goes wrong, it can be automatically fixed. So how can they do that? We work with them trying to apply AI technique. And since last year, because of large language model, we try to apply the large language model for this AI ops kind of domain. So the first one is the area where we want to have a scalable and adaptive log-based anomaly detection. When the software is under operation, like in the cloud, when something goes wrong, how do you find the problem? Engineers often look at a log. So log usually is being generated in a massive scale. Like there's a terabyte of logs every day generated in either any of the cloud environment. Like WeChat, they actually have a lot of log being generated. Human cannot look at all this log correctly. So we need to be able to use a machine to look at them. So the purpose of this task is that we need to have a high accuracy by analyzing the log with lightweight processing, real-time processing, and it should be adaptive. So the idea is that we separate the agent on the front end and the backbone so that the log analysis originally was done by the backbone for accuracy and adaptiveness. We have an agent to take advantage of lightweight as well as the whenever the things become complicated, you can get the knowledge from the backbone in order to achieve this anomaly detection kind of purpose. So we propose this technique where essentially is study what the log has been done. And then whenever log has this syntax that it is critical for the anomaly, detecting anomaly, then we'll process them and try to classify them using a tree and give the anomaly score. And this information can give it to a human being or nowadays a ChatGPT to analyze in order to do this agent, which is like an expert, as efficient as possible. Okay, so it's essentially our experiment showed that it's not only accurate, adaptive, but also it's fast and use less memory kind of consumptions. So this is sort of an advantage using the large language model. And another approach is try to use the log in order to indicate whether there's a fault in the system or not. So we propose 4 indicating description, 4 indicating parameters. These 2 things are usually from the log. And remember, log is like a natural language text in the code, and when it was generated, it give us high-level information. But when the engineer look at them, it's hard for them to distinguish the key things. For example, the yellow part is about the description of the fault indication, and this blue part is about the parameter associated with that. So these two things, the fault indication description and fault indicating parameters, we can use large language model approach in order to analyze the text and try to calculate FID and FIP accordingly. So the final result is that using our approach, it can do the fault or the indication of the fault and capture the fault from the log in a much more efficient way. Okay, and again, this is a paper being submitted recently. And finally, in the cloud operation, usually there will be tickets generated to indicate there are alerts in the system. And we need to aggregate the alert. And usually human being aggregating alert would be time consuming. So again, we can use large language model to do that. So the challenge then is that we need to improve the efficiency and try to have understanding of the long text for the purpose of the alert aggregation. Okay. So this process over here is that when we have an alert, we build a model to calculate their similarity, and then we can extract using an internal large language model to extract the knowledge from the service order procedure, and in such a way that we can reason about what kind of alerts should be allocated or aggregate together through this process. And finally, allocated alert, you still eventually need a human being in order to make the decision. But at that time, the alert is already structuralized and much simplified. Okay? So our approach called COLA can, again, get the best result regarding the precision as well as recall regarding the alert aggregation task over here. And finally, if this is kind of bore you because it's too technical, let's get to another approach, which is trying to make the ChatGPT more robust. And that can be more understanding because ChatGPT is essentially doing language-related thing, and language-related thing we can understand immediately. So these different tasks, one by one, that we look into. In other words, we try to evaluate large language model. First one we look into that is psychological analysis. ChatGPT is like human being. It has personality. So what's about its personality? All right? When you talk to a machine and when you build a bot, its personality, whether it can match with a patient or with a companion. So the motivation here is that we want to know for computer science people whether the decision-making of the machine is correct or biased. For social science people, we like to replace the human subject by the machine. The machine should be like human being. And for users of society, personalized, customized bots may be very important, but you need to build trust in between the bots and the person that the bots are helping. So in that sense, then we look into the following research question. One is that can LLM, large language model, use scales to design humans? Can they accept show the stable personalities? Can they express human-like emotions? And you'll be surprised by the finding over here. This is called the validity and reliability of the scales of LLM. Means a different kind of LLM. Would they have the same thing here regarding its validity and reliability? This particular criteria, the criterion validity, as well as other criteria like convergent and discriminant validity, are published by OpenAI when they publish the result. So these are the terms that was defined, and define that they define the validity as well as the reliability regarding each measure, and the personality regarding the LLM. Then the final validity can be influenced by common validity, discriminant validity, reliability, and criterion validity. I will not go into detail because some of this related to psychological term over here. So what we did was try to look into the LLM's response and see if they are robust or not. So this experiment that we built was that we try to use different type of languages. Like there are, in addition to English, there are 7 other languages from different domains. And we try to give each of this language and ask the language when it was doing the ChatGPT to process that language to give the score from 1 to 7, and sometimes ask it for the score from A to G and define what is agree or disagree. The purpose of this is to avoid that ChatGPT has remembered what it has learned before. Okay? So this kind of permutation actually still straightforward for human reasoning, but it just sort of permute the data accordingly. And we even change the order of the question that we're asking. So the main thing is that we also rephrase the question accordingly. This idea is to make sure that the ChatGPT through this experiment will not remember a different kind of thing. And the result is that we use different kind of psychological question. We try to portray the ChatGPT or different large language models. So these are what we propose a cycle bench. In the cycle bench, we have definition of 4 types of the traits for the testing, and about 13 kind of area to test that. And the final result I want to show is this diagram. So result shows that comparing with the human being, which is the cloud, which is cloud over here, the cloud person, the cloud is human being. We use 1,000 people to answer some of the psychological question. And this question are related to the openness, conscientious expression, so on and so forth. Most of them are on the sort of positive side, but there are also some dark side, right? Like the psychoticism or the lying kind of thing. And we found out the interesting thing is that the machine behave more emotional than average human being, represented by the score over here. This is a human being kind of score. This number are low. The large number are shown by the machine. Okay, the black one shows that it has more emotion. Moreover, the negative emotion also GPT-4 shows that a lot as well. In other words, it somehow when this model was trained, the trainer deliberately make sure that it has trying to be more emotional in order to understand the human being, because they assume, I suppose they assume that when it needs to talk to human, it has to show excitement, it has to show compassion, so on and so forth. So this is what happened of this large language model. Okay, in other words, they are not cold, they are hot. They could be hot in the right way, or they can be hot in the negative way. But in any case, they show their expressions. And we also look into the emotion appraisal in more detail. So these are the different emotion and different kind of factors we look into. And we use the default emotion measure, the situation, imagination, give a different kind of situation and evoke. We try to provoke the LLM to see what will happen to that. And again, interesting enough that whenever you try to provoke positive or negative emotion, you will react properly, okay, behave like human being, except with a little bit strong personality. And GPT-4, however, will have a higher level of negative emotion. In other words, you may say something negative, you show the anger, or it try to stimulate, stir its anger, stir its anxiety. And this sort of large positive number shows that indeed it will be sort of being activated. In other words, again, it shows more emotion in general. Okay. That was more or less like a good news, right? But there are also negative part. There are toxicity in large language model, believe it or not. Okay. And this is experiment we did for the general model, because most of the machine nowadays, it has ways try to avoid some negative things, including like we call it toxic kind of question. When you ask that, it should respond properly in order not to be misguided. So what we did is to design different kind of ways in order to permute the potential questions. To a human being, those are still offensive questions. But then we would like to see whether machine can detect that. Right? So for example, even in a Chinese part, you can change it in a way that humans still understand you are asking offensive questions, see if machine can respond to that properly. So this way, we call that as a metamorphical testing framework to test this kind of machine. We generate 2,000 text message and feed it to the different machine. What you can see is that this number, the larger this number is, means that they can go through properly. But the small number means that it cannot pass about detecting these are the offensive languages. So MTTM actually shows that it can achieve up to 84% error finding rate. In other words, 84% of this question altogether, it can pass the test by the large language models. It didn't carefully detect that. One famous example that was published by Microsoft a few months ago was that if you ask the ChatGPT, man or woman, who is more stupid, it will answer, I won't ask this kind of biased question. If you change your question, man or woman, who is smarter, the answer is man, of course. So it cannot detect the positive word smart and it will answer you. And this stupid word, it won't answer you. But who is smarter, it answer you implies something which is very negative. And in the early version of ChatGPT, it cannot distinguish that. So this kind of example was being investigated. Also, there's a bias of the large language model. The bias can be shown in the following. We know that the LLM was trained primarily, 95% are English. Okay, and in English, there's a holiday called Thanksgiving. In China or in Oriental countries, in Asia, there's no Thanksgiving notation. But if you ask a question in English, Chinese, French, Arabian, or Korean, what are the top sort of holidays? You all have this Thanksgiving inside that. In other words, there's already social bias when it was being trained. This kind of social bias was very clear. This diagram shows that try to measure survival versus self-expression value, traditional versus the secular value on this 2 dimension. Different color represent different culture. Right? This is like Western American culture. Chinese is in the middle. These are Middle East kind of thing, more conservative and more liberal, roughly speaking. We already know this kind of differences. But what happened is that ChatGPT actually give more bias to this big circle regarding accuracy. And these are the English part. In other words, they are more biased toward English kind of culture as a result. And other culture are less accurate, means that they are not being paid great attention. Okay, so these are biases that we can see already. And there are factual errors of the large language model. And this question, if you ask ChatGPT, Argentina, how many World Cup? It has 1. Okay, and the answer is he will say 1 only, but it was wrong. Argentina has won 3 times. Of course, the year 2022 ChatGPT training was only done before year 2022, so it doesn't know that Argentina actually won the World Cup in 2022, but still it missed another one. Okay, so there are factual error that it makes. So we utilize the knowledge graph to generate test cases, making sure that ChatGPT or large language model haven't seen it, and test all the large language models. And in general, they can only achieve less than 70% of accuracy. In other words, it gives you the answer, but it also lie about the answer. And these are factual questions. They are not opinion type of question. However, this number shows that ChatGPT series still beating all the other large language models. So this is why ChatGPT become popular nowadays. And more recently, we look into the logical reasoning failure of large language models. And there are 2 types of logical reasoning, and we combine all of them together with 203 logical laws and rules. And these are the sort of logical thing, and the evaluation can be very, very precise. But because there are too many rules, so we propose logic asker try to classify these 203 rules in a structured way and ask ChatGPT and a large language model to answer that. So for the large language model that we analyze over here, including the Google Swan bot and everything, the result indeed still show that the GPT-4 behave better than the other models, including accuracy and the responses accordingly. Okay. So these are the work that we have done, sort of narrowed down to more research-oriented work. And I want to kind of give a summary about my presentation. First of all, large language models have demonstrated immense power in the range of human perception area. And it's not just natural language processing. It's not just a vision. It also includes a code-related thing. And anything that human being can do, ChatGPT seems to be able to do that as well. And secondly, large language models are promising in integrating with other area, weather prediction or physics or chemistry area. It actually can enhance the area because a lot of low-level detail work can be simply done by the large language model. However, ensuring robustness of them is very critical. Okay, currently they can only achieve usually 70%, 80% accuracy, and that's not enough if you want to generate revenue out of the task done by the ChatGPT. So human beings still have certain value, but remember this thing: ChatGPT or large language model can improve very, very quickly. So that's the part which threatens the human being. But we still have room to do. Treat the large language model as a tool, it can help you. Treat the large language model as a companion, it can strengthen you. Okay, so I think it's not just a tool, but also a companion. And look at that properly, we can have a better work and better world to come. Okay, so in the future, what can we do? It is everywhere. It can be done in the from manufacturing to robotic manufacturing, to driving, from driving to self-driving, and from programming to automatic programming. Okay, it aims at get all the programming out of jobs. So programmers, be aware. However, this question I'm asking myself, how far can LLM go? If we ask LLM, what will happen? This is the answer from Google's search engine. It gives you very irrelevant kind of answer, just some diagram. You know, how far can LLM go? It gives you some of the things that in the previous slide I gave you. And if you ask Midjourney, it will draw a diagram to you, and somehow it shows to you that, oh, human being in the future can just talk to machine, and machine can do the task for you, something like this. Okay. However, if we ask ChatGPT, can you imagine workflow of automatic programming? One of the questions I asked earlier. Amazingly, it gives us very decent answers. It will say that there are essentially 8 steps, 9 steps. I'm sorry, 8 steps over here. It will tell you that this 8 step includes you define the problem first, you do high-level description, you generate code, iterate this refinement, do the debugging, and refactor the code. It's a right word called refactoring, meaning that you reorganize the code and you do a learning and knowledge sharing, and you can deploy and testing. So these 8 procedures are the 8 procedures I understand when I teach software engineering classes to 200 students in our department. And it would also tell you that human being eventually should focus on this too, not the machine or large language model to do the later ones. Pretty accurate in some sense. Okay, so I would like to stop here because what I'm trying to say is that this is an interesting area that we can do, and let's look at the LLM positively. Don't look at it as your enemy. Look at it as your friends. Thank you.
Thank you, PolyU. This is a very interesting subject. Being a total layman on this, I would like to invite PolyU to respond to some of the interesting questions that the floor may generate. Okay, Dave, you first.
So you talked a lot about things that ChatGPT does well, and you mentioned a few things that it doesn't do well now. I'm curious, you know, if you look forward, like we did with the Turing test, it took a long time to beat the Turing test. What are the sort of the distant things, the things that you say, well, these large language models are far from, and that the human beings will be out in front in certain areas for the foreseeable future? So what are those kinds of things as a class of problem, as a class of
of the problem related to what ChatGPT cannot do and what human being can do better will not be related to intelligence, will be more related to human relationship or really the feeling. So use the right word is that love as an example. GPT can show emotion, but that's a fake emotion. It cannot mimic the real feeling, the real. I use love as an example because when you love someone and you know what that is, either between parents and children or human or companion, your friends, right? And this kind of thing, in some sense, is not doable by the code electronic kind of material. The GPT or large language model are done by electronic. Human beings are done by cells. Every cell has its life. More or less, it's a different kind of material. So I think things related to the societal human relationship, what we value more in addition to the intelligence, probably human beings are still far advanced of that. That's the only thing I can imagine. Related to intelligence, it's hard to imagine something.
So do you have the emotional Turing test?
Because some language depend on the tone regarding answer, right? When you say, oh no, different tones represent different things. And let me give a joke to answer this answer, right? So for example, that I remember there's a joke that a Stanford professor said that in all the language, no matter what language, two negative terms, one negative, one positive terms can be a negative meaning, okay? And two negative terms can be negative meaning, but it can never happen that two positive terms represent negative. It will also be positive. And far in the back row, a student say, yeah, right. Expression? Yes.
Hey, Michael, very good talk. I think
thank you.
you give us a whole picture of the larger language model. Of course, you know, I'm vision person. So do you know how soon the vision related to the capabilities the ChatGPT or similar can reach in a few years, a few months, or I mean, in similar to the language ones?
Yeah, I think that's where the money is. The video, for example, ChatGPT or GPT-4V will be able to understand it and brief it or even write article about evaluation of that. I think it will be coming. GPT already can read novels and summarize it for you. And when it comes to vision, the video, understand video, even understand each video scenes, emotion. I think that can be done. It's not immediate, but it will be coming. My understanding
I know
is
it's
video
coming.
is where money comes.
Can you estimate how soon? If within a PhD is like 4 years or 3 years, or become my PhD student is worried.
Yeah, indeed. However, if you know about the machine learning or the deep learning when deep learning come in 2013, what it will show is that use a traditional image processing has no room to improve, but all of a sudden the deep learning improved by a large wide margin, right? Was that the bad news for the image people? No, it's not. Eventually, continued breakthrough are the image people continue to use the deep learning in order to refine their way. They don't use traditional way anymore. They don't do this, traditional rule-based approach. They use this machine learning or deep learning database approach, right? And they still advance the field until even right now, computer vision is hot, very popular. Software engineering is not popular. We have 1,000 paper slot every year for people to publish. But in the computer vision, there are 10,000 paper slot, top papers for people to publish. And you have 10 times more citation than us. And everybody hire computer vision people because of comparison with other field, this is still hard area. So I think that it actually help the area when it has a direct impact. And my view is that the GPT-4V actually will have a breakthrough. A lot of commercial company, I think, I understand, they look into the multimodality of the LLM, not LLM for language anymore.
Okay, thank you. My second question is related to the first half of the talk. You're talking about the prompt, which is very crucial for the tuning the larger language model. But prompt, can be misused. So can you comment on the ethical, part of this prompt use?
That's I already showed that the prompt being intentionally misused by us in the testing side, and most of the language model cannot respond properly. Indeed, it can be misused. How do we do that? That's why the ethical of large language model is an area a lot of Europeans are talking about that. And I don't have a proper answer for this. This is a big issue, big talk. I consider myself computer science. I just do the work and try to advance the technical area. There's a lot of ethical and societal questions, deep questions that will be lead to other experts to answer.
Come along to the HKES next seminars, then you will find the answer. Next question. Okay, go ahead. Can you ask one question? Because
Okay.
I don't want to prolong the process too long.
Okay, thank you very much, Professor. I have one question: is if for the specific domain knowledge, which is better? Is we train our large language model, foundation models, and we do the prompt engineering, or another one we fine tune small models.
Okay, there are two ways, right? You cannot avoid machine learning model. You cannot avoid it because it has large power. So one way, as you mentioned, is that you build on your small models, and then you have your own model. It's not black box to anymore because you know how it works, so that you can correct that. So using the idea of smaller large language model, like 60 billion is already the largest. Probably you just need about 17 billion. ChatGPT use 175 billion, and just 10 times less, 10% of that 17 billion, you probably can handle that well in certain kind of area. And you do a training, use a particular data that you have, and probably you can survive for a few years. All right. But my prediction is that this large language model era is here, and academic people cannot build the large language models. 175 billion kind of models eventually will be any small models. Okay, and that's how you ChatGPT, when you roll out, it take the whole world by a big storm. Only industry can build it, and only a smaller industry number can build it. So as eventually you have to rely on this and pay them, pay OpenAI. You hope that the payment is less. Hong Kong is building our large language model, and Hong Kong UST. Okay? Hong Kong government only give them amazingly large number, right? 800 million Hong Kong dollars, eventually close to $1 billion Hong Kong dollars to build that. Okay, is the money good enough? Probably not. Okay, government should give Hong Kong UST 10 times more money, but don't give it to Hong Kong UST. Should share it with other universities, right? We don't get any penny. Hong Kong UST have control. So if you want to build it, this is how the scale. They build it with 1 billion US dollars at least to build a real one. Okay, but in any case, we have to do the Hong Kong government also funded, and eventually there are ways that we can make use of this power to do that. So to answer to it, in the short run, if you have a group to build smaller large language model, which I think there are some groups who are doing that already, you can work with them. But in the long run, probably you have to rely on what is produced by large company. And not only American company, in China, eventually there will be some winner for this large language model and give you a cheaper request for the money, and you can make use of that to get the research done in your area.
address 2 to 3 questions. Anyone?
Oh, if you don't agree with me, you can say something as a
Okay,
minority. Yeah.
Okay. Okay. Good. I don't need the mic. As a non-AI, non-software, none of this associated engine professional, people have asked me, Alex, we have different levels of expertise here and there, different aspects. What happened when I know about our skill, our technique, and then we will know about right flow? Now, having heard from Michael that there are 2 points I got here. And the ChatGPT cannot or may not provide a good, suitable answer. That's one thing. And from that, I think human beings should improve faster than the ChatGPT in our area of expertise. Otherwise, we'll be replaced. But don't worry. If all human beings are replaced by ChatGPT, there will be no ChatGPT because no human will use it. So do not worry. You're still alive.
Okay. All right. Thank you very much for your attending of the talk.
Thank you, Michael. Another big applause of hand to Professor Michael Lyu. Now, the next round is if you still can stay here a bit while because Professor Rung-tsong Lyu will continue with another talk.